Lines are going to be something that will continue to come back up in just about every math class. Lines you also use to predict behavior, so you see linear equations in applications in other classes like economics, um, population growth, you're making predictions about behavior. Calculus, the idea of a derivative is all slope of a line. So depending on how far you're going to be going, you will need to be good with lines. It's one of those things that you just see over and over again. And the trouble with it is you don't have just single questions. I could have one line and could ask you any number of different questions about it. Whereas, for instance, with solving a linear equation, I can just give you the equation, no directions, and it's pretty clear what you're supposed to be doing. But that's not the case with graphing lines. So you do need to know what is being asked for. And that's where this summary comes in. We have different forms of lines. Slope-intercept form is where the equation is solved for y. Y is mx plus b. You can read off the slope, and b is the y-intercept. This is also called function form because if you solve an equation for y, you can write it as a function. F of x is mx plus b. So function form and slope-intercept form are the same. Point-slope form comes from the equation for slope, and you use it to get an equation when you know a point and the slope. Y minus y1 is m times x minus x1. So x and y are just the variables x and y, but x sub 1, y sub 1 are the specific coordinates of a point. Standard form, ax plus by equals c. And every line can be put in standard form. This is useful in solving systems of equations, and also this is what lets vertical lines be counted as lines as well. Even though they have a slope that is undefined, they can be written in standard form. Slope. Slope is a rate of change. That's going to be critical in calculus. But we can remember slope as the rise over the run, the change in y over change in x, vertical change to horizontal change, y2 minus y1 over x2 minus x1, and listing the coordinates x sub 1, y sub 1, x sub 2, y sub 2 on a point, on your points if you're using the slope formula can help avoid switching x and y coordinates, which is bad. So comments there. Then parallel lines. Well, if two lines are parallel, their slopes are the same. So parallel lines have the same slope. Perpendicular lines have slopes that are negative reciprocals. The product of the slopes is -1. With the exception of vertical and horizontal, there they aren't negative reciprocals, but simply vertical and horizontal lines are perpendicular. So here, with this example, we're in slope-intercept form because our equation is solved for y. The slope of this line is 2/3. The y-intercept is 0.7. Line parallel to this. Well, parallel would have the same slope. This has slope 2/3. Parallel line would have slope 2/3. If we were doing perpendicular lines, this line has slope 2/3. Negative reciprocal slope, flip and negate it. -3/2 would be the slope of the perpendicular line. And symbols parallel and perpendicular. Vertical lines. We can't put a vertical line in slope-intercept form, but we can put it in standard form. If you have a vertical line, your slope is undefined. Rise is any different number, but we don't run anywhere. We don't go left or right at all. The equation for a vertical line, y could be any number, but x is fixed. So x is k. Pick a number for y. X is always the same number, so you get to pick values for y. Horizontal lines, the slope is 0. With a horizontal line, x could be any number, but y remains fixed. So here for a horizontal line, your equation will be y equals some number. When graphing lines, intercepts are important points. X-intercept, x is any number, but y is 0. So to find an x-intercept, let y be 0, solve for x. The y-intercept, where you cross the y-axis, y could be any number, but x has to be 0. So x-intercept, let y be 0, y-intercept, let x be 0. 2 points determines a line, but when you're getting started in particular, it's good to always find a third point to be sure you haven't made a mistake. Be sure points are labeled when you're graphing these by hand, arrows at the ends of the graph, and the line fills the plane. And on word problems, use words. If you set up an ordered pair with x standing for this in words and y standing for this in words, it's going to make solving the word problems much easier.